I'm going to run through Unit 2 as mentioned, the project life cycle, and then we're going to start looking at some concepts when doing cost estimation. So we're going to look at applying the project lifecycle production of information, understand the basics of cost estimation, and then allocate the different cost estimations to your project lifecycle. So the concepts that we're going to look at in the second section of this lecture is going to be very important for your assignment. Whenever you build up your rate and you make some assumptions, you're going to take these concepts into consideration. So firstly, looking at chapter 1, the basic principles of cost planning and cost control. So I would expect you to actually have a look and go through your study notes for more detail. So this lecture is more just highlights some of the important items that's in there. So it's a bit of a almost like a summary of what's contained in the study notes. Okay, so cost design ratio. So there's always a cost design ratio that one needs to look at. Your design is not an easy task, and skill and knowledge, information, and time is needed. So you need experience whenever doing a proper estimation. The success of a project is not necessarily dependent on whether you do it successfully, but it goes hand in hand with actually the experience, the satisfaction that you enjoy and the client enjoys on the project, compared to traditional scientific model for problem solving. This is the concept that I explained on whenever you do an estimate on a project, it's always a hypothesis until it's done, and you can actually compare what the hypothesized cost would be in relation to what it actually worked out on. And then the design observes the need of the developer. Hypothesis is formulated and tested on the basis to find an optimum solution, and the historical data is used. So you always use data on which you base your estimate. It's never just something that you do a thumb suck on. It's based on real information that you had on previous projects. And then a hypothesis can, however, not be tested timelessly, although with the advent of BIM and modeling, you can actually get test your hypothesis a little bit more than we could in the olden days. It's always dependent, it's also dependent on whether the rates that you use for your estimate is correct or not. Okay, and time and cost is limited, so you can't continually test and go back to the drawing board. At some stage, this project has to come to light so that the developer can actually make money out of it, or stay or utilize the building also. Okay, then remember I showed the spaghetti challenge, so I just put in the link here so you can copy and paste that into your browser so that you can have a look at it. Then the cost design ratio. Cost is most important single factor directly influencing the design. So unfortunately we have this constraint usually on our projects that there's not enough money. Sometimes you do get nice projects where the client doesn't really care about the cost too much. Obviously he wants good value for money, but on most projects cost is usually a big constraint. Cost design ratio is influenced by the cost, which is independent. It's independent because the client knows, or he has the funds. The size of the project is independent and also dependent on the cost. The shape, same thing, also dependent or independent and dependent on the cost. And then you've got your specifications is independent and dependent on the cost. So there's a big ratio between that, although it leans towards the mostly dependent on how much funds is available. But if you play around with the size, the shape, and the specifications, you can usually find a middle ground, and this is where the cost engineers comes in their own, or the QSs with feedback on what options would be best. Okay, so the main thing, like I said, is finding the balance. Then your design process. Usually you have your analysis, your synthesis, and your evaluation. So you've got your analysis of what the need is, you try and make it material, and then you evaluate it, will this actually fit within the budget. The real design decision is made in the first two phases of the project, and research has shown that 80% of the cost of the building is usually made up in these two phases. Only 20% can be controlled in the last third of the project. Okay, so this is a good example, the size and shape of the project. So this is similar projects of size or areas per square meter, although the Apple campus had a few advantages. It had a lot of land to work on, so it didn't need a large project to or footing actually to accommodate the building. So just for interest's sake, with the Apple campus, with all the tech and so on, one would actually think that the Apple campus would be more or less expensive, although with the tech it worked out quite a little bit more because it was a larger construction. It worked out at about 853,000 square meters, and it worked out at 5,858 rand dollars per square meter, whereas the Burj Khalifa actually worked out at a cheaper rate. It only covered 309,000 square meters, but it came in at 4,846 square meter dollars per square meter, because it looked at the facades and the installation. It didn't require that much tech, and it was built over a much shorter period, which saved a bit of money. So one would have expected that the Apple campus would be cheaper than the Burj Khalifa, but then the Burj Khalifa actually worked out cheaper in this case. Okay, so looking at cost planning concluded, and the conclusion of this section. Cost information is thus essential for the first two phases. Traditionally though, cost is only really looked at phase 3. It's usually dependent on the emphasis from the client or the QS or the project manager on how the cost is looked at the beginning of the project. Usually good project or developers do focus a lot on the cost on stage 1 and 2, because they want to make that informed decision whether they're going to commit to this project. So usually when you get to stage 3, you're already committed to this project, because now you're spending a lot on fees for this project. So the money starts flowing a little bit more, so there's much more commitment. So the compilation of the cost information during the first two phases is referred to as cost planning. And then the systems approach, this is in short, you can go through this, please read through the study notes. This is basically where you've got the input you've got your input, your processes, and your output. And with us, the stages 1 to 2, each phase, the output of the one phase is the input to the next. whereas at the end of stage 6, that output is usually the input for your stage 1 of your new project. Okay, systems approach, cost planning, cost control. So I'm just going to go through these quickly. You've got your open systems or your closed systems, where your controls and changes performance automatically by reacting to the information produced by itself. So it's basically the cost is influenced by the design of the building. It dictates what type of finishes there can be, or the type of finishes dictate what the cost would be. The size of the building will dictate the cost of the building, the location, etc., etc. Whereas open systems doesn't make provision for its own control. So usually when you start doing your cost estimation or planning in phase 3, it means that no proper cost information was generated in the first 2 phases, and then you basically start with an open blank way of looking at items. So your open systems doesn't make provision for internal control. It is usually when you've got a client who's got a lot of money who doesn't really care, it's a bit more open than you're not constantly trying to look at the cost. You just do the design and you do the cost, and you continue with that. You don't go back to the drawing board and see if you can improve the design to bring down the costs. So system serves the following functions. It's got identify the input, the predecessor, what is the purpose, maintains reliability and validity. Is this information tangible? Because, for instance, the information that you use, you cannot use Cape Town rates, for instance, in Bloemfontein, because the going rate is different, and the material cost would be different, etc., etc. Okay, and then usually it rectifies malperformance. So it's maybe not the correct word, but it rectifies the design to actually to get into the correct parameters. Okay, and it identifies the users, the set objectives, and the limitations. Then your cost planning and control systems. You've got your cost planning, cost control can be seen as a closed system. And I've got the double E again. This week we looked at the architectural outputs in our systems of cost planning, cost control. So we just basically touched on or discussed that the design does influence the cost. So that's a little bit towards the end of this lecture. Okay, and then we've got our architectural guideline or gazette that I'm just going to run through, which is basically our 6 stages. So remember we've got our general project plan, and we've got our 6 stages up to our closeout, and then each stage has its different outputs from the architectural side, and all of this information influences what the QS can do. Same with stage 2. We have a basic design or your concept design where that is done. Stage 3 is where you actually start developing your design. What type of finishes are you going to use? It's basically just finalizing the design and putting it on, starting to put it on paper. And then you've got your documentation procurement. This is where you prepare your documentation required for local authorities for submission, and then you start developing your construction drawings for your contractor. And then the tender is called. And then stage 5 is where you've got your contract, you've got information that's detailed drawings, for instance, are how a flashing should be fitted to the rafters, etc. How should the skirting be fixed to the walls? That type of finishing is then conveyed to the contractor. Then you've got your closeout. where you facilitate the project closeout, including the preparation of the necessary documentation to effect completion, handover and operation of the project. So that's your closeout report, etc. So the contractor's obligation with respect to the building contract has been fulfilled, and the architectural professional shall issue the certificate related to the contract completion. Completion certificate, QS, is usually the final account. Provide the client with as-built drawings, this is for the architects, and relevant technical contractual undertaking by the contractor. Usually it's like a occupation certificate that's issued, depending on what type of project you're busy with. If it's a public project for government, you would have a occupation certificate, like for instance your health and safety, or your health inspector will come and inspect your building. They will ask, is this, did the structural engineer sign off on all the SABS documentation, is the electrical COC in place, etc., etc. Cost planning, cost control subsystems. The element of cost planning and cost control are interdependent and continuously attract each other. The other, this is a little bit over simplification of the situation though. So then I just highlighted here how thinking non-linear in process, you can just go through this. This is not too important, but basically you've got your emphasis, you define, ideate and prototype and test. So basically you've got your concept, you've got your definition, you've got your identification, which is your design process, and then you've got your prototype, your working drawings or your model these days, and then you test it, and that information is then fed back into the items. But like I said, this is not too important. You can go through this. This will just explain the subsystems a little bit more. Okay, cost planning, cost control subsystems. Okay, very important to go through. Cost planning, cost control systems consist mainly out of 3 subsystems. You've got your output of the one serves as the input of the other. So you've got your assignment stage. You establish the scope basically. You look at the scope and you do your design and you pre-tender activities. You look at your cost goals, produce from sketch plans or the design, which serves as a basis for the detailed plan of cost planning. Obviously, it's the same with your design. You've got your concept designs or sketch plans, which later is developed into your actual detailed plan. And then you have your post-tender activities, which is your cost plan development for detailed drawing serves as an implementation for the next phase or the new project or so. Each system regulates the next. Okay, we've touched on that. And then the cost planning and cost control are self-regulating in fulfillment of the cost goal. So it's basically a bit of a repetition of what I've said earlier on already. Okay, and then I just added this little slide that you can have a look at. And then we get to chapter 2, estimates of buildings. So this is where we actually get to what type of estimation methods is used. The goal is to obtain a prediction of the proposed building where detailed information is lacking or where it is expensive, tedious or time-consuming paying for the process. So you want to get the most optimal solution for that current situation where you are. It doesn't help that you try and compile bills of quantities when you're only at stage 2 or 3, because there's still a lot of things that can change. So you don't want to spend too much and pay the QS too much fees during this stage of the game. So usually estimation is the best solution that can be used. The investor has to evaluate the financial plan. This is what I said earlier, that after stage 2, usually they assess whether they're going to continue with this project or not. Funding has to be used optimally to ensure to select the most economical design solution. Funding is distributed economically over the project, and costs are spent within the limits of the approved budget. The aim of the budget is thus to give cost involved and serves as basis on which the cost planning and control is done. Okay, and then you can go through page 32 for some additional information. Okay, the basics of cost estimation. So it's the process of awarding monetary values. I think this is probably awarding. Okay, awarding monetary values to certain products and services to try and estimate what the total cost is. Now, there's always additional costs that that the client has to be aware of, like for instance the fees, VAT, that has to be added, external works, payments of loans, etc. Usually payments of loans, we're not too involved in, that is for the client. But there's like establishment costs, connection fees to the municipality, etc., etc. An estimate has to be done quickly. Immediate problem solving is needed, and it should be reliable. Guesstimates is a big risk on a project. One has to sit down and look at all the possible influences on the project. The cost estimator should apply knowledge, experience, and discipline. He should further have a valid knowledge of composition of building. Basically, he just needs to understand that if you take out this wall, it might not necessarily save money, because now you suddenly have to put in structural reinforcing in the ceiling to open up this space. So that's the basics that the cost estimator has to look at. He has to know what the influence of the one professional is on the other. So for instance, like I just mentioned, if the structural engineer changes something on this side, it may influence the look and feel of the architectural side as well. Where will the electrical ducting go? Will it fit within this flat roof design? Is there enough space? Air conditioning ducting is usually a big challenge. Does the surfaces clash with each other? That's the things that he has to look at. Thus, rates and quantities. You have your rates and you have your quantities. Those are the two parameters that influence the cost. So if you want to bring down costs, you can either reduce the rates through the specifications or so, or you can reduce the quantities by altering the size of the project or the design shape of the project or the design. Again, you can have a look on page 32. Okay, then you've got your design process. The accuracy of the estimate is determined by the stability of the market, the time of the estimate, estimated training, knowledge, and experience. Accuracy of information is very important. If you select a certain type of tile, for instance porcelain in comparison to ceramic, it will have a big influence on the cost. Estimator understanding building costs. Just on the information here is a simple thing which I experienced once is where the architect wanted a stainless steel expansion joint within the tiles and not a PVC one, and then the cost per meter difference was quite big. The PVC or the plastic expansion joint had a cost of about 20 Rand, 25 Rand per meter, whereas the stainless steel expansion joint with a rubber filling in between was almost 150 Rand per square meter. So that was quite a big cost implication that we had there. So we actually saved a lot of money because of the tiling area was such a large area. We could rather put in the PVC expansion joint instead of the stainless steel one, and we still got the same look and feel by just looking at the color of the PVC one that we put in. So that is options that one can actually look at on when you do your estimation and so on. Then ability to applying methods and estimation. Completeness of information. Is everything included? Is there not maybe a on the drawings a footing that's maybe not shown, or a external building housing, some mechanical insulation that's not shown on this drawing but it's shown on another drawing, which may not have been supplied to the QS. That type of thing. The completeness of information is very important. Does it meet all the client's requirements? That also happens quite a bit, where the client comes back later on, but they actually wanted this also in the design. Then the number of variations. How many variations is there on the project? Important decisions are made from the initial cost estimate. Yeah, like I mentioned. Okay, then we've got our methods of measurement. So I've looked at this. This is straightforward. Remember, we've got 9 different estimation methods. We've got our single price methods. We've got our single price detailed methods. And we've got our detailed methods. So each one has 3 estimation methods that we're going to look at. There's more estimation methods, although we only included the 9 most commonly used ones. So very easy to remember. Whenever you answer a question and you have to look at all of them, remember they're divided into 3 categories, and there's 3 underneath each category. So our single price methods. So we use our historical data always. So they are limited and entail the allocation of single tariffs. So it's usually a measurement times a rate. So for instance, you've got our unit method, which is the number of beds, the number of keys for a hotel development, etc. So you've got the number of beds times the rate of per unit when you use your historical building. Then you've got your area method, the one most commonly used. You work out the area, you times that area with a rate per square meter. Then you've got your cube method, which is basically the same. You take your cube rate from a historical building and you apply it to the new cube interior that you actually use. Applying experience is very important. Okay, so this is for your task 1 that I'm going to look at. You need to tweak your rates for the situation. Then we've got our single price detailed methods. So we've got our story enclosure method, our parametric system or method, and then we've got our elemental analysis method. So the analysis method is just the higher end of estimation, but you will understand that as soon as we get into the actual examples of those. So this is a example of a elemental analysis method where you've got your primary elements and so on, and you've got your cost estimation here, but it's based on a per square meter area on this side, which is times with a rate to get to that estimation. You will see you've got your alteration works and your external services also here on as extra items. Preliminaries, we'll still get to that. That's basically the contractor's establishment costs and our construction contingencies. Contingencies we'll also talk about. It's very important to note that is usually at this stage of the project there's still a lot of unforeseen design items that we haven't looked at, so we usually build in a bit of a contingency to make sure that we're covered for that. As the information gets more and more, you can actually lower the percentage of your contingencies. Then you've got your single price detailed methods. This is what we've looked. So the accuracy of the unit rate can also be increased by using more detail of the historic building to derive the rate. So this is an example that I included or discussed in class, is where you had a previous development that had certain elements towards a new development. So we had a new squash court that was being developed, but it had there's no single item that could be used the same. Like for instance, you had a gym with wooden flooring, and your squash court also had wooden flooring, so you could use the rate per square meter rate for your wooden flooring and apply it to here. But it had a concrete roof, which you couldn't apply to your new building. So you took this section and the IBR area, or the construction of the build of this roof, and applied it to the installation here. Although you can see that this was more a double pitch or a gable type, end type of construction, which doesn't really work out the same as this new development. So what I would have done is I would have lowered the rate slightly to accommodate for this. So then you can take that information and use it like that. But this example, there's a proper example of this that we're going to look at as well. So this is the story enclosure method that we usually use. Okay, so what happened here is you take out the items which is applicable to the project. You look at what the rate per square meter is, and the exterior brick walls you can see that's the same. You didn't have interior brick walls, so you could leave that out. Same with your concrete slabs, you didn't use that. Your waterproofing was also not included. And then what you do is you take all of these items, the rand per square meter, and you estimate what your new rate per square meter would be. You times it with your new building's area. Then you add your exterior work, and then you add some special items. Like for instance, this new building had extractor fans, so you have to allow for that, which was not included in the previous building. So you need to evaluate your buildings according to that. Then you can see that P's and G's of 8% was added, and then a contingency to that, and VAT as well, to get to a new estimated cost of this building. So this is the process. Although don't break yourself on it to understand everything now exactly. Just understand that for instance, your external works is calculated separately, and special items also calculated separately. Single price detailed methods, different BOQs items is used. So you usually use your BOQ from a previous project to get certain rates for your new project. Take more time than standard single price methods. Okay, and this is just basically the difference between your single price methods and your single price detailed method. More information is available. Okay, so this is then we get to our detailed methods. Our detailed methods, this is where most of the information is already available. Now you can actually in detail work out what your square meter floor area would be for your tiling, for instance. Your skirtings, you can measure all of your skirtings, etc. And again, it's divided into 3 different methods. So we've got our elemental analysis method, but it goes up to component level. And then you've got your comprehensive quantities, and then you've got your accurate quantities as well. So you can see your elemental estimation is now broken down. So here you've got your primary elements divided into all of these items here, and you can see this is just a summary. So you can calculate your total cost, your area of your building, and then you just calculated what your rate per square meter is based on your elements that you measured. So scrolling down further, this is now for your substructure is divided into more detail, and you can see now it's measured in different units, per meter, per square meter, per cube. You add some percentages for items that you don't really know, like hard rock, soft rock, etc. Then you get your floor construction, structural frame, etc. Okay, so not too important to know all of these differences just yet. Then our bills of quantities. Very important to note is that we've got bills of quantities. So our bills of quantities comprises out of many bills divided into trades. So now you've got your trades of earthworks, your trade of masonry, roof carpentry, which includes your roof construction. Except if it's steel construction, then it will fall underneath structural steel. For instance, so the subcontractor would be a steel worker. So if you think about your trades, it's the tradesman that actually installs those items. So roof coverings, you will have specialist roof covering installers, and thus all of the roof sheeting, insulation, your gutters and everything like that will be included in this bill. Okay, very important to note, your bills of quantities always has an item number so that you can easily reference it. Your description is very important because this becomes a contractual agreement. How are you going to pay the contractor? If he says he didn't price for a clip lock heavy duty industrial galvanized roof sheet, you can go refer back to the document and say, but here it was shown specifically that he has to price for it. So he can't go back. The rate that he provided here is fixed. We cannot change that that rate. The quantities is usually also provisional. Depending, some contracts you may have fixed quantities, so it doesn't matter whether it can only change by a variation, not by remeasurement. Okay, and then you've got your quantity column where everything is measured. You've got your rate for that item, the installation, which includes the profit, overheads, etc. And then the total cost is estimated. And then all of these rates are added up to get to the contract sum. Okay, then you can go through the uniform rules. I'm not going to go through all of them, but it basically is whenever you do the measurement, you need to go through all of these steps to ensure that you have all the information and that it's done correctly. Okay, and then I just included this typical question. You can have a look on the slides PDF to look at it, but this is a typical question that I might ask in a test or in an exam. Okay, then we get to shape, that explanation of the shape of the building and the size of the building and so on. But I'm just going to stop this lecture here. I see it's becoming quite a large file, so I'm just going to stop it here for now and then make a separate recording for the second section of the lecture.